The last thing we're going to look at here is a quick application where we want to use matrices to determine if there is a combination of the foods shown in the table below that can provide exactly 14 milligrams of thiamine, 37 milligrams of riboflavin, and 9 milligrams of niacin using the information given. Now, before I get into this example in too much detail, I want to say that this is following a process, or at least it leads to a process, from material in a class called Operations Research. It's a class some of you guys might get to, but that's a few years down the line. I guess this is a little preview. You may not remember, but hey, maybe so, maybe no. Anyway, here we've got this table of information that we're going to be working with. And with this problem, I'd argue the hardest step is setup, seeing that what we need to do here is think about each of these vitamin contents that we need to hit as being in terms of an equation, while each of the foods that are going into them we'll be thinking about as a variable in that equation. Excuse me, the foods that will have the vitamins, not the vitamins in the foods. Wait, not the foods in the vitamins, geez. Anyway, maybe it helps a little bit if we think about this by turning it a bit on its side. So you have an arrangement that turns out more like what we're going to end up with. But the long and short of it is we're going to take that system, we're going to take that table, translate it into some equations, like so, and then we'll take those equations and turn them into a matrix that we can work with, where our matrix should have form 3, 1, 3, 14 in the first row, 7, 5, 8, 37 in the second, 1, 3, 2, 9 in the third. And from there, we want to end up using Gaussian elimination or Gauss-Jordan elimination to try and solve this. And what's going to happen here is it might not work out the way we want to. Not just because we're in this section, though. But anyway, we've got this system. The first thing to do, because you've already got a row that has a 1 in its first entry, is just flip it over to get that 1 on top. So we're going to flip row 1 and row 3 to get that there. And then we're going to take the new row 3 and clear out the cell value in there. So we're going to knock out the 3 by subtracting 3 times the new row 1, which means that 3 is going to become a 0. We're going to have 1 minus 3 times 3, so 9 for negative 8. And then 3 minus 3 times 2, 6, gives us negative 3, along with 3 times 9 gives 27. 14 minus 27 leaves negative 13. So that's where our third row is going to be. They do the same sort of thing with the second, except now you're multiplying by 7. And we'll get in there for the second row 0, negative 16, negative 6, and negative 26 from the operation R2 minus 7R1 to get column 1 in form 1, 0, 0. And from here, you should be able to look at rows 2 and 3 and see that row 2 is just 2 times row 3. So without doing any more math, you should be able to tell that there's going to be a problem here. But just to be sure, we can reduce these. In this case, I'm not going to do any rearranging, really. Like I said, when you're taking this kind of problem, you can approach it in many ways. I'm going to add 1/2 times row 2 to row 3 to clear out row 3, which would just leave you with zeros down there. And then I'm also going to simplify out that row 2 to leave it in form 0, 1, 3/8, 13/8. And then from there, because that last row contains nothing of value, it'll pull right out. And we'll be left with 1, 3, 2, 9, and 0, 1, 3/8, negative 13/8. Not the very prettiest picture, to be sure, but From there, we can follow down a path of substitution. We'll let y be equal to, make that equals a little nicer, 13/8 minus 3/8 z. And from there, we can substitute that into x and get x is equal to 9 minus 3 times 13/8. And I'm going to run out of space here, but that's okay. Minus 3/8 z minus 2z. That 3 is going to multiply in there, get 39/8. 9 minus 39/8 ends up being 33/8. And then here, negative 3 times negative 3/8 becomes positive 9/8, but minus 2 leaves minus 7/8 z. So at the end, our solution is going to be a set of values that here, because we solved it in this way, like we usually do, but for no better reason than consistency, will depend on z, and is a form 33/8 minus 7/8 z, 13/8 minus 3/8 z, and then z can do whatever z chooses. Z is free because our solution depends on it. So technically speaking, we have an infinite class of solutions here, but if we think about this realistically, remembering that what we're working from is something in terms of these food values, the vitamin content of 3 foods, this says we can take any amount of food C that we want, but really, if we take too much food C, we'd end up with negative amounts of foods A and B, which isn't really possible. So realistically, we can take anything for food C up to 4 1/3 ounces of it. But this is what we're looking for our general solution.